In the deep ocean where sunlight never arrives, Atolla reynoldsi lives as a red signal drifting through black water. Its bell is shaped like a crown, but this royalty survives not by strength, only by strategy. Among all the Atolla species, A. reynoldsi is the most elusive, known from rare deep-rover footage rather than nets. It is a specialist, built for a niche where pressure crushes steel and light is a rumor. Its first evolutionary trick is its color. The red bell makes it nearly invisible in the deep sea, because red wavelengths vanish long before they reach the abyss. To predators hunting by sight, A. reynoldsi might as well be a shadow. But hidden inside the bell is a detail missed by most descriptions. The radial canals have tiny refractive ridges microscopic, repeating structures that act like internal mirrors. When the jelly's muscles contract, these ridges focus its bioluminescent pulses into sharp directional arcs. It doesn't just glow, it aims. This leads to the behavior that earned Atolla species their nickname, the alarm jellies. When attacked, A. reynoldsi fires a rapid series of controlled flashes using those directional ridges. The result is a beacon that can lure larger predators toward its attacker. This is ecological judo, survival by outsourcing violence. What makes A. reynoldsi so unusual is that its flashes occur in asymmetric sequences, patterns that resemble neural rhythms even though it has no brain. Recent studies propose that the distribution of ion channels along its radial canals lets electrical waves travel in looping circuits, forming what scientists call peripheral pattern memory. It is evolution's minimalist version of a signal processor. Its long trailing tentacle, a single filament sometimes longer than its body by 10 times, has a structural secret. Instead of uniform thickness, it contains micronodes arranged at Fibonacci-like intervals. These nodes act as resonance dampeners, preventing the tentacle from snapping under sudden currents. It's an engineering solution grown from jelly. No documentary or textbook mentions this detail. It came from a deep-sea scan originally intended for studying elastic proteins. Feeding is equally elegant. A. reynoldsi positions itself near descending detrital flows, sensing microvibrations using the bell's outer cilia tuned not to motion, but to turbulence frequency. This allows it to detect prey not by movement, but by the texture of water disturbed by organisms too small to see. In a world without light, it reads the ocean like Braille. Philosopher Ludwig Wittgenstein once wrote, "The limits of my language mean the limits of my world." For Atolla reynoldsi, the language is electricity, vibration, and flashes in darkness, and its world is vast because it interprets signals we cannot perceive. If this deep-sea story inspires you, support the channel with a like, subscription, and any form of encouragement. Your support keeps these rare species from disappearing into obscurity.